In this section, we shall see about chain rule multivariable. Before this, all we knew about chain rule in single variable, where we have a function of x inside, and we have another function of g on the inside of the function of f. Where we have the derivative of the whole thing, it would be the derivative of the function on the outside times the derivative of the function on the inside. And now, if we change y to f and x to g, will be the f of y times the of x, like the usual how we had it. Where if we like now, we're also like we should also, if we also want to add find the derivative of y in terms of t, it would be dy over dx times dx over dt. So in using this, we can now we'll be able to find the derivative of a new function with z, where the function of x is x and y. Where if you want to find the derivative of z in terms of x, we need to find the partial derivative of z in terms of x times the derivative of x in terms of t, plus the partial derivative of z over the partial derivative of y times dy over dt. So for examples, we could use z is equal to x squared plus y squared, and x is equal to 2t and y is equal to 3t, where the derivative of z in terms of t would be the partial derivative of z times the derivative of x dt, plus the partial derivative, well, the partial derivative over here of x, my bad, plus the partial derivative of y times dy dt, where the partial derivative of x is 2x from here, and the derivative of dx over dt is 2 from here, and the partial derivative of y would be 2y from here, and the derivative of dy over dt would be 3 from here. That's how we get all these four numbers. And once we multiply everything out, and then if we substitute all the x's and y in here, x and y, we will get 8t plus 18t, which will be equal to 26t. Now, for the second one, we now add a z into the function, where we have to use another function. Instead of z, we use w, where x squared plus y squared plus z squared, where x is equal to cosine t, y is equal to sine of t, and z is equal to e to the t. Where the derivative of w in terms of t would be the partial derivative of x times dx dt, plus the partial derivative of y dy dt, plus the partial derivative of z dz dt. Where the partial derivative of x is 2x times the derivative of dx dt would be negative sine of t, plus the partial derivative of y is 2y times dy dt, which is cosine, plus partial derivative of z is 2z, and the derivative of dz dt would be e to the t right here. And then once we multiply everything out and substitute all the x, y's, and z's, and cancel all the like terms, all we're left is equal to 2 e to the 2t.